Okay, gang, today we're going to talk about the second big thing in calculus, besides the derivative, and that would be the integral, or as I have it written here, the antiderivative. Okay? They're the same thing, the terms are used interchangeably, but more commonly known as the integral. Okay? So, in previous videos we've talked about derivatives, and we've talked about how to find derivatives. Well, now, what we're saying is, we're given a function such as f of x, and we're saying that function is the derivative. So what is the antiderivative? It's kind of like saying, with derivatives, it's saying, here's the question, what's the answer? With antiderivatives, it's saying, here's the answer, what's the question? So it's going backwards. We're going in reverse, so to speak. So we mark an antiderivative by this symbol here. That little thing kind of looks like a skinny S. We mark it by that symbol, and it is a antiderivative of f of x times dx. Now you're probably wondering, where does the dx come from? There's a very good answer for that. Okay, the derivative is often denoted by dy dx is equal to f of x, where f of x is some function. Okay. Well, the antiderivative means we're going to solve for dy. It's just called finding a differential. So dy equals f of x times dx. So simply solve for dy by multiplying both sides by dx. So dy is our integral, and then you have f of x times dx. Okay? So that's a quick overview of where that comes from. Okay? So now let's take a look at this problem here. We're told, find the antiderivative, or the integral, of x squared plus 3x plus 2, and then you have your dx. Okay? Just to show that the dx goes with the whole expression, I like to have parentheses around it. Otherwise, it kind of looks like the dx just goes with the 2, and we know that's not so. So, we have a polynomial thing here. We have a polynomial. So, with derivatives, we did, to find the derivative of a power, such as one of these, we took we multiplied by, we brought the exponent up front, we multiplied by that exponent, and we subtracted 1. Alright, well now we're going to have to do that in reverse. Okay? So, the integral of x to the n power is equal to x to the power of n plus 1. Okay, so this time we're adding the exponent, and we're going to divide by that same power, by n plus 1. Okay, so here, so the integral from x of x to the second would be x to the power of 2 plus 1 over 2 plus 1, which would be x to the third over 3. Do that up so we can see what's going on. And now let's look, so that's the integral of x squared. Integral of 3x would be 3 times x squared over 2. Okay? And then integral of 2 would be 2x. Okay? So if you were to differentiate this or that, okay, you would go back, you would actually be going back to, derivative of x cubed over 3 would be x squared, 3x squared over 2 would give you 3x, 2x would give you 2. So this time we're going backwards. We're starting with the derivative and figuring out what's the original function. Okay? So we have x cubed over 3. So the derivative of, the integral of x squared plus 3x plus 2 dx is actually equal to these three parts added together. X cubed over 3 plus 3x squared plus 2x. Okay? And then there's something else we have to add in. Okay, this is what's called an indefinite integral. And it's called indefinite because we could add on any constant value, c, okay, any constant value c, and this would still be a very good, any constant value c, and we could take the derivative of this and still come back to x squared plus 3x plus 2. Okay? Alright? So, because we know that the derivative of a constant is 0, it doesn't matter what c is, but it just knows that it's there. So anytime we have an indefinite integral, we have to add on b plus c. So our final answer then is x cubed over 3 plus 3x squared plus 2x plus constant c. And that is how you'd find a basic indefinite integral.